Hello students, in this class we are going to learn how to find second derivative of a parametric equation. We also find concavity of a parametric equation. Since our equation is parametric, so x and y both depend on a parameter. Let us say here x and y both depend on parameter t. So dy over dx is given by dy over dt divided by dx upon dt. After finding first derivative, we will find second derivative d2y over dx square. This is nothing but derivative of dy over dx with respect to x. Since dy over dx is a function of t, so we cannot differentiate dy over dx with respect to x. So we will use chain rule and we differentiate dy over dx with respect to t, and then we multiply dt over dx. We can also rewrite this equation as derivative of dy over dx with respect to t divided by dx upon dt. So by using this simple formula or this simple formula, we find second derivative. Please note, if second derivative is negative, then our parametric equation is concave down. If second derivative is positive, then our function is concave up like this. Let us see some questions so that we are able to understand how we find second derivative. So here parametric curve is given by x equal to t square minus 2t and y equals to 4t cube minus 2t. So let us differentiate this with respect to t. So dx upon dt is given by 2 times of t. Here we use power rule. So derivative of t square with respect to t is simply 2t. Derivative of t with respect to t is 1. So derivative of 2t is simply 2. Now let us find dy over dt. We know derivative of t cube is 3t square. So it becomes 4 into 3t square, which is 12 times of t square minus 2. Now let us find dy over dx, which is nothing but dy over dt, which is 12t square minus 2 divided by dx upon dt, which is 2 times of t minus 2. Let us divide numerator and denominator by 2. We get t minus 1. And here we get 6 times of t square minus 1. Let us find second derivative d2y over dx square, which is nothing but derivative of dy over dx with respect to t. So 6 times of t square minus 1 divided by t minus 1 divided by dx upon dt. Here we use chain rule. Sorry, here we use quotient rule, which is derivative of u over v is nothing but v square v into derivative of u minus u derivative of v. This is something called quotient rule. Here we use quotient rule, and dx over dt we had already find. This is 2 times of t minus 1. So let us use quotient rule here. So it becomes t minus 1 whole square. Now t minus 1 into derivative of numerator, which is simply 12 times of t minus our numerator, which is 6 times of t square minus 1 into derivative of denominator. Derivative of t is 1 and derivative of 1 is 0. So we leave that term divided by dx upon dt, which is nothing but 2 times of t minus 1. Once we multiply these two terms, it becomes 2 times of t minus 1 cube, and our numerator becomes 12 times of t into t is 12t square minus 12t minus 6t square plus 1. We can easily simplify this. After simplifying, we get 6 times of t square minus 12t plus 1 divided by 2 times of t minus 1 cube. So basically, this is second derivative of given parametric equation. Let us see one more question. Here x is t square plus t, y is 2 times of t cube minus 1. We have to find the interval in which this function, this parametric equation is concave up. We know a function is concave up if second derivative, which is d2y over dx square, is positive. So let us find d2y over dx square, and for that first we need to find dy over dx, and in order to find dy over dx, first differentiate x with respect to t. We get dx over dt is 2 times of t plus 1. Next, let us find dy over dt. So differentiate y with respect to t, use power rule. So derivative of t cube is 3t square. So 3t square into 2 is basically 6 times of t square. Derivative of constant is 0. So we can write minus 0. Now dy over dx is equal to dy over dt, which is simply 6t square, divided by dx upon dt, which is nothing but 2t plus 1. Now, for finding second derivative, let us differentiate dy over dx with respect to t first. This is dy over dx. And then we differentiate, then we divide it by dx upon dt to get d2y over dx square. So here we use quotient rule. This is simply 6t square divided by 2t plus 1. This much divided by dx upon dt, which is nothing but 2t plus 1. So let us use quotient rule. This is 2t plus 1 whole square, 2t plus 1 into derivative of 6t square, which is simply 12 times of t, minus 6t square into derivative of 2t plus 1, which is simply 2, divided by 2t plus 1. So basically these terms get multiplied again and we get 2t plus 1 cube. 12 times of t into 2t gives us 24 t square plus 12t minus 12t square. After subtracting, we get 12t square plus 12t divided by 2t plus 1 cube. Here 12t is common, so we can write this as 12 times of t into t plus 1 divided by 2t plus 1 cube, and this is nothing but second derivative. Now let us rewrite this again. Our second derivative is d2y over dx square is nothing but 2t plus 1 cube, 2t plus 1 cube into 12 times of t into t plus 1. Now, if we set these linear factor equal to 0, once we put d2y over dx square equal to 0, we get t equals to 0 or t plus 1 equal to 0. So once we put t equal to 0, we get 0. Once we put t plus 1 equal to 0, we get negative 1. So negative 1 is somewhere here. Once we put 2t plus 1 equal to 0, we get negative 1. So basically, we get 3 factor. One is negative 1, one is negative 1 by 2, and other is 0. And these numbers divide the number line in 4 disjoint interval. Let us check the sign for each interval. If we choose a function, if we take t more than 0 and plug here, suppose we take 1, which is more than 0. So our numerator is positive, denominator is positive. So we get a positive number. Now, if we take a number between minus 0.5 to 0, let us say we put negative 0.4, then our numerator is negative because t is negative 0.4 and 1 minus 0.4 is 0.6. So basically this is product of negative and positive. So we end up getting some negative number. And here, this is 1 minus 2 times of 0.8. So basically this is 0.2 cube. So basically denominator is positive, numerator is negative. So ultimately we get some negative number. Similarly, we plug a number between negative half to negative 1, we get a positive fraction. Similarly, if we plug a number less than negative 1, say negative 2, then this is negative, product is positive, denominator is negative. So we get some negative number. So we say d2y over dx square is more than 0 if t belongs to interval -1 to -1/2 union 0 to infinity. So if t belongs to this interval, then we can say, or we can rewrite like t is more than -1 and less than negative half, or t is obviously more than 0, then our function is concave up. And when t belongs to these intervals, then our function is concave down. Thank you. Hopefully all of you are able to understand. However, if there is any doubt, then let me know in the comment section. Thank you.